So this lesson is the fill in the blank proofs. It's the first of 2 videos that we'll have. Okay, so given this diagram here, all right, we see a couple statements. Now it says in the first one, measure of AEB plus the measure of BEC equals the measure of AEC. Why do we know that? What's the reason behind it? So we know that if we take one angle plus another little one, and we can make a bigger one. So this is the angle addition postulate, right? Or just addition, either one, right? If we look at the second one, AE plus ED equals AD. So that's saying AE plus ED equals AD. Well, that's the same idea, right? We take one part of the segment, another part of the segment, and that equals the whole segment. So that's the segment addition postulate. We talked about these in the last unit. Okay, if we look here at E is the midpoint of AD, we know that AE is congruent to ED. So AE is congruent to ED if E is the midpoint. So if we know that E is the midpoint of AD, okay, we know that this is going to be the definition of midpoint of a segment, right? All right, if you look at E as the midpoint of AD, that's given to us. AE is equal to 1/2 of AD. This is given to us as the midpoint theorem. And that's because we know that AE plus ED equals AD. By substitution, I know that AE is congruent to ED, so I really have AE plus AE is equal to AD. We know by multiplication, really, we have 2AE equals AD, and then by division, I see that AE is equal to 1/2 AD. So instead of having to write that out every time, we can just call that the midpoint theorem. So if we look here, E is the midpoint of AD, that's given to us, and we want to know why EC bisects AD. So if E is the midpoint, okay, we can look here and say by definition of a bisector of a segment, or a segment bisector. So that means that this line right here is going to bisect AD, so these two are congruent. If EB is the angle bisector of angle AEC, that's given to us, the definition of angle bisector would say what? What do you think that would say? Okay, so that would say that angle AEB is congruent to angle BEC. Okay, so EB is the angle bisector of AEC, so we know that these two are congruent. So the angle bisector theorem would say that angle AEB is equal to 1/2 of the angle of AEC, right? Because if I know that this whole thing here is being bisected by this guy, then this guy is 1/2 of the whole angle. Okay, so angle 6 is a right angle, that's given to us. So that means that if we look at RS being perpendicular to TV, what would be the reason for that? Well, the reason would be the perpendicular lines theorem. I'm just going to use THM as theorem. Okay, if RS is perpendicular to TV, then how is angle 8 a right angle? Okay, so going backwards, like we said before, so if you look at above, 6 is a right angle, so RS is perpendicular to TV by the perpendicular lines theorem. If we go the other way and say RS is perpendicular to TV, how is angle 8 a right angle? Well, that's the exact same theorem, perpendicular lines theorem. So it goes both ways. Okay, so RS is perpendicular to TV. How do we know that angle 6 is congruent to angle 7? We know this because these two lines are perpendicular. So if they're perpendicular, they automatically form right angles. So that means if two lines are parallel, then we have congruent adjacent angles. So perpendicular lines gives us congruent adjacent angles. Okay, so this one's a little bit trickier, all right? So we have a flow proof that's been set up here. So this is the style of proofs that ultimately we're going to get to. And before you create the flow proof on your own, I've given you all of the statements. You just have to come up with the reasons. So if we look over here to the left, we see that we have a diagram here. We're given that RS is equal to PS, ST is equal to SQ, and I want to prove that RT is equal to PQ. So first of all, I like to mark up my diagram. So if I'm given that RS, this guy here, is congruent to PS, and ST, which is this guy, is congruent to SQ, how can I prove that RT is equal to PQ? So first at the top, we always write our given statement. So RS is equal to PS, so that's given to us. ST is equal to SQ, well, that's also given to us. So now let's go to the next step. RS plus ST equals PS plus SQ. Well, it looks like we took RS plus ST, PS plus SQ. So if we know that this is equal to this and this is equal to this, if I add this guy over here and this guy over here, am I changing the problem at all? No, that's just addition, right? Because I'm not changing either side. If I'm adding 1 to both sides or 2 to both sides, it's still even. So now we need to think, okay, RS plus ST equals RT. Okay, so if we think about that, right, that's going to be our segment addition postulate. All right, the same would be true over here. PS plus SQ equals PQ. And we know that because PS plus SQ gives us the whole thing. So that's also going to be our segment addition postulate. Okay, now a flow proof, we use these arrows to say what leads to what. So for example, this given statement led here, and so did this one. So that's how those given statements were used. In order to say that RT is equal to PQ, what do we have to know? So if I look here, okay, so RS plus ST, oh hey, that's right here, okay? So that means that here's the RT for that side. PS plus SQ, well that's right here, so that's where the PQ came from. So all we did was plug in things that were congruent, right? So that means that this is really just substitution. All right, so that tells us that we've proved because we've used this guy and this one and this one. So each piece of our information was used to get from our givens to what we had to prove. So why don't you go ahead and take a moment and prove this. Try it, struggle with it. Measure of NSQ, so the measure of NSQ right here, is congruent to the measure of PSR. Okay, you're given that. And I want you to prove that angle 1 and angle 3 are equal, that they're congruent, okay? So take a minute, struggle, pause the video, and then we'll go through it. Okay, so thinking about that picture that we had, okay? So you should have that picture in your notes. If you don't, back it up and copy it into your notes. Okay, so we're given that the measure of angle NSQ equals the measure of PSR, and I want to prove that the measure of angle 1 equals the measure of angle 3. So first of all, I'm going to start with what I know, right? So I know that the measure of angle NSQ is equal to the measure of PSR because that is given to me, okay? I also know that the measure of angle NSP plus the measure of angle PSQ equals the measure of angle NSQ, and that's because of the angle addition postulate. okay? I also know that the measure of angle PSQ plus the measure of QSR equals the measure of angle PSR, and that's by the same reason, the angle addition postulate. Alrighty, so now I know that I see here I have NSQ PSR, NSQ PSR. So I can plug this and this in for their respective quantities over here. So I'll do that in a different color. So we have the measure of angle NSP plus the measure of angle PSQ equals the measure of angle PSQ plus the measure of angle QSR. Okay, and that's just by substitution. So for us to get to this point, I had to use this idea, and this idea. Okay, so now from there, I can see that I have measure of PSQ on both sides. So if I subtract that, I see that I have the measure of NSP equal to the measure of angle QSR. And that's by subtraction. All right, so I had to use this idea to feed that guy. Okay, now off to the side, I know, right, that the measure of angle 1 is equal to the measure of angle NSP, and the measure of angle 3 is equal to the measure of QSR. And I'm just going to say that's reflexive. And that's because we know that the measure of angle 1 is the same thing as NSP and 3 is the same thing as QSR, and that they're just having different names. So I just put that off to the side. And that's ultimately so I can see that the measure of angle 1 is equal to the measure of angle 3. And why do I know that? Well, I know that because measure of NSP is here, QSR is here, I just have to plug in. So that is by substitution. All right, and I had to use both of these ideas for me to get there. Now, don't stress if you didn't understand how to do this. We're going to have plenty of time in class, and we're going to have a flex day coming up in order to go through this. So don't fret, don't be scared. We'll take this as slow as we need to, okay?